All right, going to start 8.1, basic integration rules. I'm just going to go at it. This is a review of all Chapter 4 and Chapter 5 material. So we're going to have some use substitution, trig identities, long division, stuff like that. So let's figure it out. Let's start with the first one. Integral 14 x minus 5 to the 6 dx. This is a straight u substitution. So we're going to let u equal, just autofocus. U equals x minus 5 du equals dx. So when we substitute this in, I want to replace 14 dx. So you can say, hey, I'm just going to multiply by 14. You can pull the scalar out. It doesn't really matter. So this is going to be 14 u to the 6 du. Then we take the antiderivative, add 1, divide by the new. So adding 1, 7, divide by 7 is going to be 2u to the 7th plus c. But we don't have our boundaries, so we got to go back to our x. This is going to be 2x minus 5 to the 7th plus c. Okay, number 2. We got another u sub here. Okay, it's going to be the integral of 7 all over z minus 10 to the 7th. I'm going to pull that up and make it z minus 10 to the negative 7 dz. So this is just going to be u equals z minus 10, du equals dz. And if you notice, kind of a common theme here, if what's inside our u has a derivative of 1, you can treat it just like a basic base in 4.1 and just do the power rule. So this is going to end up, as we substitute, you could pull the 7 out, so really you only need to replace the dz here, up to you. But this is going to be u to the negative 7 du. So when we add 1, divide by the new, that's going to be negative 7 6 u to the negative 6 plus c, which equals negative 7 all over 6 z minus 10 quantity to the 6 plus c. Number 3, okay, we're going to separate. So I'm going to make this the integral of v dv plus the integral of 3v minus 1 to the negative 3 dv. This right here is going to be a u substitution. Some of you had practice with this. Just to save time, I'm just going to say, hey, to compensate for this, we're going to have to multiply by 1/3. So this is going to be the same thing as 1/3 integral of u to the negative 3 du. You could just rewrite this again if you want, since we haven't done it yet. So this is going to end up being v squared over 2. Add 1, divide by the new. This will be negative 1/6 u to the negative 2 plus c. Remember, u equals 3v minus 1. du equals 3 dv. So that's where we'd have to multiply by the 1/3 here. So equals v squared all over 2 minus 1 over 6 3v minus 1 quantity squared plus c. Okay. Number 4. We got the integral of t squared minus 3 all over negative t cubed plus 9t plus 1 dt. Degree is 1 bigger than that. I have 2 terms here. Don't know what's going on with the focus. Sorry about that. I just keep pushing buttons. I wonder what this does. It just makes it stay, I think. I want it to stay. All right. I'm going to let u equal negative t cubed plus 9t plus 1. So du equals negative 3t squared plus 9 dt. So right now I have the integral of u in the bottom, but I want to replace the t squared minus 3 dt. Well, here, if I multiply by negative 1/3, that'll actually get me that. Okay, this will become the t squared, and this will become the minus 3. So I'm going to replace this right here, the t squared minus 3 dt, with negative 1/3 du. And if you know your chapter 5, section 2, 5.2, this is the integral of the natural log, this is what results in the natural log. So it's going to be negative 1/3 natural log of u plus c, which equals negative 1/3 natural log of negative t cubed.